Today's is 5-1 and it's midsegments in triangles. So I'm going to just tell you what a midsegment is and then show you what a midsegment is. The name kind of tells you, essentially, I guess, what a midsegment is. It's a segment that goes through midpoints. Yes?
Are we going to have as many proofs as last chapter?
No, very few proofs in this chapter. Like none on any quizzes or tests. Maybe a few in the homework. But all right, so midsegment is a segment. Oops. I changed out the tip of my stylus and now it's extra sticky. Doesn't want to write an E. That's horrible. Oh my goodness, come on. Sorry. There it goes. A segment connecting the midpoints of two sides. Okay, is a midsegment. So it will look something like this. You'll have a triangle. And if I find a midpoint on this side, okay, so those two segments are the same length, you have a midpoint. And then I find a midpoint over here so that these two segments are the same length. A midsegment is the segment that connects those 2 points. So my midsegment would be right here. Okay, so we would call this a midsegment. There's a theorem that goes along with midsegments, and I'm curious if you have any guesses what that theorem might say. So is there anything you notice about that line? Yeah.
Well, something about halves.
Something about halves. Okay. Why?
Because it's in between the halves.
Okay. Yeah.
I'd say something like the leg and a
But it's not necessarily a right triangle, so there's not going to necessarily be a hypotenuse.
You just formed a quadrilateral and a triangle that share a side.
I did do that. Okay. Is that a hand up, Julia? No? Yes. Did you get it?
Parallel.
Parallel. Okay, so you've touched on both things, actually. This is called the triangle midsegment theorem. Triangle midsegment theorem. Okay, and here's what it says. If you have a midsegment in a triangle, then the segment is parallel to the third side. Got a ninja in the house now. And it's half the length, okay? So if I'm looking at, well, let's just write this out. If you want to write the definition, here it is. If a segment joins the midpoints of two sides of a triangle. Okay, so essentially if you have a midsegment, right, is what they're saying, then the segment is parallel to the third side and half its length. Okay, a little wordy, I know. So essentially what we're saying is if you look at that picture up above, again, I would say that this segment is parallel to that one, okay? And I could say that if this is a length of 2x, then this one would be a length of x, right? It's going to be half as much. Or you could say it as, let's say we have this one. So again, these are going to be parallel. If this one is x, then this one is 1/2 times x. Okay, so I don't care if you think of it as the one is double the other or the one is half the other. I feel like sometimes it's just easier to not deal with a fraction for people, but you can think of it either way. One is going to be half as much as the other, or one is going to be twice as much as the other, depending on which one you're thinking of as your starting point. Okay? Questions on that? Okay. I will leave that there if you're still writing, but I'm going to start drawing a picture here. For example 1. Let's say you have a triangle, and you have a midpoint here, and a midpoint here, and a midpoint here. Okay, and I'm going to connect all of those. So technically right now I have 3 midsegments, right? I connected the midpoints and got my midsegment. So if this is A, B, C, and then D, E, and F, I want to know which segments are parallel. What's parallel to DE? You could say CB, you could technically say CF or FB, right? But we'll say the whole thing. So CB would be parallel to DE. What's parallel to AB?
DF.
That'd be DF, right? Okay, and then the third one, we would say AC is parallel to what?
Yeah.
AC would be parallel to EF. Okay, so at times they're just going to ask you for the parallel segments, which I feel like that gets seen pretty easily for most. I think the part that's a little more difficult for people is the whole cutting a segment in half thing. And if it's just a number, people do fine with it. If it's like the side is 20, so the mid segment would be half of that, so it's 10, right? But it's not always just numbers. So I'm going to show you both. I'm going to show you where it's numbers, and I'm going to show you where it's not just numbers. So let's start with example 2 here. Let's say we have this is E, F, G, and then we have a midpoint. And just so you're clear, this only works if it's a midsegment, right? If it's cutting a side in half and connecting to another point that's a midpoint, then you can do the whole parallel and half of the length. So this would be H, J, and K. All right, and then I'm going to give you some lengths. So let's say EF here, this whole side, has a length of 60. And HK, so this whole length, is 40. And this whole length is 100. Give you a second to draw that out. All right, let's say I want to know the length of HJ. Can you tell me what that would be? If I want to know HJ. How'd you get it? It's equal to what? HE?
No, EG.
EG. Gotcha. Yes. EG is related to HJ, right? It's going to be half as much. HJ is half as much. So if EG is 100, then HJ is going to be half of 100, or 50. Okay, so HJ is 50. What would FG be? The green. It'd be 80, right? Now you have the midsegment. Midsegment here is 40. So if the midsegment's 40, then the segment across from it, the parallel segment, has to be twice as much. So that would be 80. So we would say FG is double the 40. So 80, okay? Notice the difference. And you guys are intelligent people. So just think about this as you do it, right? Does it make sense for me to have a 40 at HK and then to tell me that this segment, FG, is 20? No, okay? But that's what some of you are going to do because you're just going to be so used to cutting things in half. So just make sure you're paying attention that when it's getting longer, you're doubling it, right? If it's getting shorter, you're cutting it in half, okay? Take your time on those. What would JK be? It would be 30 because this segment here, FE, is 60, right? We're going to cut that in half because we're getting smaller. So you would say that, oops, not FE. JK is half of 60, so that's 30. Okay, questions on that? So you're either cutting it in half or you're doubling it, depending on what you have. All right, then we start throwing expressions in. So that's this next one. Okay, so there's a midsegment. This has a length of x minus 1, and this side here has a length of 52. What do you do? So you have x minus 1 for the midsegment, right? You have 52 for the side across from it. How can you figure out what x is? How can you solve for x? What do you have to do with your expression or with the other side? What can you do to figure that out? What do you think, Daniel?
Well, you could do x minus 1 equals 1 half times 52 and then solve algebraically from there.
Okay, so there's really two ways you could do this. We can cut the 52 in half, right? Because half of that 52 is what this should equal. So if I cut 52 in half, then x minus 1 would be half of 52, or x minus 1 equals 26. And then you just solve, add 1, so x is 27. Okay, what else could we do? If we aren't cutting this one in half, what do we have to do to this one? You could double it, okay? So you have that option. My only concern with that one is that people forget to distribute. So if you're confident that you're not going to forget to distribute, then you can do this one too. But you'll notice you're going to get the same thing. So if we distribute that, we get 2x minus 2 equals 52. So add the 2, and 2x equals 54, and then divide by 2. So x is 27. So it really doesn't matter which method you choose. You're going to get the same answer regardless. So choose the one that makes sense to you, okay? Just make sure you don't cut one in half and double one, because that won't work. So you either cut one in half or you double one or the other, okay? Questions on that? Okay, last thing. We're gonna say, any swimmers in here, like competitive swimmers, you compete? He says you don't. What? No, I'm just wondering why Trevor says you don't swim and you're so confident that you do. I was a swimmer back in the day. I was a sea lion. It was awesome. Although the meets were not awesome. You had to like sit all day. Did any of you do competition swimming when you were young? Nobody? It's not really a thing around here as much. Did you? Did you like it? I like loved it and hated it all at the same time. It's just the meets, you would like sit for an entire day. You'd put up a tent and you'd like hang out all day and wait for your one little competition, which lasted like 30 seconds. Is that how that goes? Yeah, well, at least you have 18 minutes to compete, huh? Anyway, okay, so we're going to pretend that you like to swim and that you're training for your swimming competition. You could do this with anything. It doesn't have to be swimming, but we're going to use swimming right now. So there's a lake. You go on vacation with your family, and your coach says, you better stay in shape while you're gone or you're not going to be able to compete. So there's this really long lake, and you're going to swim across it. But your coach says you have to swim 2 miles every day. It's a long time. Lake Verhoeven, yes, okay. So you don't know how far it is across this lake, and there's no way there's a measuring device to get you across this lake. So instead, what we're gonna do is we're gonna find a way to measure this lake. We are gonna use geometry. So you start at the end of the lake here. Okay, we're gonna start right here. And we're gonna walk till we're at a place where we could walk straight across. And we're just gonna put a stake in the ground. Okay, and we're gonna say that as you walk, every stride is about 3 feet. So it'd be different for all of us, right? But we're just gonna go average here. So we walked 35 strides to get to here. Then we're going to go again another 35 strides to right here and put another stake in the ground. Okay, so these are congruent. Any guesses my next move? You walk what? Not another 35.
Walk to the other end of the lake.
You're going to walk to the other end of the lake. Okay. So we're going to go like this, and we're going to walk all the way here. Now, think about this. If we're trying to find a mid-segment, essentially, is what's going to help us here, how can I get halfway across? How do I know where that halfway mark is going to be? But how do we know perfectly where that is?
It's too high.
It's not necessarily 35.
It's 70.
It's not necessarily 70. Here's the thing. If I walk all the way across to here, and that was 236 strides, what do I need to do to find the halfway mark? Cut it in half and walk back that many strides, right? So 236 cut in half is 118. So you're going to go back this way 118 strides. So that now this is 118 and 118. Okay? So you have stakes in the ground that you're going to connect now. If I walk across here and find that it's 128 strides, then how many strides would it be across the lake? Right. Take that 128 and double it. Oops. My ruler's not cooperating, sorry. Okay, so that distance across would be 256 strides. So to figure out how many feet that is across the lake,
So
multiply it by 3. So you're going to go 256 times 3, since each stride was going to be 3 feet, and you get 768 feet. Okay? Do you know how you'd figure out that in miles? 5 tomatoes.
first you have to know miles.
What?
First you have to know what miles.
Right, which is 5 tomatoes. How many of you learned 5 tomatoes? 5,280, 5280, 5280. No? That was a Mrs. Alford thing, I think. Wasn't it? Was it Alford or was it? Oh, it was Schulte that did that. Oh, Samuelson does it too? I think the only reason we do it is because that's how everyone comes and tells us that they learned it. So, if we want to convert 768 feet into, or figure out how many of those we need for 2 miles, we know that 1 mile, you won't have to do this, by the way, I'm just going because I gave you a number. 1 mile is 5,280 feet, right? So if I want 2 miles, then you got to take that 768. So you could say 1 mile is 5,280 feet. So 2 miles is how many feet, right? So if we double this, yeah, I did that weird. You don't have to do it this way. Divide by 768. You'd have to go 13.75 times across that lake. That would be a journey. But anyway, don't worry about the algebra so much. I just need you to make sure you understand the mid-segment idea, okay? Here's the thing. Tomorrow, you're going to take a quiz. It's very short. It is 2 questions on mid-segments like this, okay? So at the beginning of class tomorrow, we'll correct the homework. We'll go over any questions you have. You'll take a 2-minute quiz, and then I'll teach you the next lesson, okay? Questions?